Okay, so let's talk about how to solve rational inequalities. Now you'll see that this looks very familiar to you if you remember solving quadratic inequalities where we used a number line. When we used the number line there, we had to set it equal to 0, put the numbers on the number line, and then check intervals. And we did the same thing when we had radical inequalities, except we also had to include domains. So rational inequalities are going to be much the same. So the steps are you find the excluded values in the inequality, and remember excluded values when the denominator is equal to 0. Then you solve the associated equation, so you replace the inequality symbol with an equal sign, solve. Use the number line to find the solutions, and you'll put the excluded values and the solutions to the equation on the number line, and test intervals, and then you'll write your answer. So, first example, solve for x, and we have the inequality here. So my excluded values would be anything that makes any denominator equal to 0. I only have one denominator here, it's x minus 1. So my excluded value is 1. That's step 1 completed. Now I'm going to solve the associated equation. So I'm going to take that inequality and replace it with an equal sign. And we do that because in solving, we would be multiplying both sides by a number that we don't know if it's positive or negative. So the inequality direction would sometimes flip around, sometimes not. So it's safer to solve it as an equation. So I'm going to get an LCD on both sides. You can see there's only one denominator, it's x minus 1. My left-hand side is already over that. My right-hand side, though, needs to be multiplied by x minus 1 on top and bottom. Now I can multiply both sides by the LCD and solve this like a regular equation. So now I have an solution and an excluded value, so I'm going to do my number line. So I'm going to draw a number line. On this number line, I'm going to put my two values that I found, my excluded value and my solution. And since this doesn't include 1, I can put an open circle there. And my original inequality didn't include the solution, so I can put an open circle here. And now I need to test each of these intervals. So basically, I'm going to plug in numbers less than -3, between -3 and 1, and bigger than 1 to see which intervals work. So I'm going to test the middle interval first, so checking when x is 0. When x is 0, I get 7 over -1 is less than 2. That definitely works. So the stuff where 0 is works. I'm going to check -4, which is less than -3. So that would give me -20 plus 7, which is -13, over -5, which is 13/5. It's like less than 2. -13 over -5 is like 2.6. That is not less than 2, so that doesn't work. And if I pick something bigger than 1, say 2, I'm going to get 17 over 1 is less than 2. Definitely not true. So that doesn't work. So that means my solutions are this middle part, which I need to write my answer for. So I'm going to write x as an element of. Neither of those points were included, so I'm going to have open parentheses. And it goes from -3 to 1. So find your excluded values, solve your associated equation, put the excluded values and the solution on the number line, test your intervals, write your answer. Now, here's a problem that's a little more involved, but it's the same process. So first thing we're going to do is find our excluded values, but this time we have two excluded values. X plus 1 can't equal 0, so x can't be -1, and 1 minus x can't equal 0, so x can't be 1. Now I'm going to solve my associated equation. So rewrite it as an equation. Get an LCD. LCD here would just be the denominators times each other. So I'm going to get x times 1 minus x to switch this one to the LCD. And then 3 minus x gets multiplied by x plus 1 to get it over the LCD. Now I can multiply both sides by the LCD. And I'm going to go ahead and multiply this out. I'm going to get everything onto the same side. So let's see, I have 3x minus x, which is 2x, minus another x, which is x. So I get x is negative 3. So now I'm going to put my number line down, put my excluded values, and they are excluded, so they have open circles. I'm going to put my solution, but this time, because my inequality had an equal sign, when I put it on the number line, it's going to be filled in. And now I have 4 intervals to test. So let's test negative 4. So that will give me negative 4 over negative 3, less than or equal to 3 minus negative 4, which is 7, or 1 minus negative 4, which is 7/5. So 4/3 is less than 7/5. So that's 1.3 repeating is less than 1.4. So that is true. Wait, yeah, 1.4. So that is true. I'll test negative 2. So let's see, negative 2 over negative 1, less than or equal to 3 minus negative 2 over 1 minus negative 2. So 2 is less than 5/3, not true. Now I'm going to test 0. 0 over 1 is less than or equal to 3 over 1, so 0 is less than 3, that's true. And now I'm going to test 2. So 2/3 is less than or equal to 1 over negative 1, definitely not true. So my solutions are this interval and this interval. So when I go to write my answer, x is an element of, starting at negative infinity and going to negative 3, but this time the negative 3 is included because it was a solution and my inequality had the equal sign. And then union negative 1 to 1, but neither of those is included. And there you go.